Oh, sorry, for the first part, I didn't record. Sorry for this one. But anyway, for the second part, I will not make this kind of mistake. Oh, yeah. Okay, sorry, it's my bad. So, and then let's talk about the 22. Vector. Probably I use too much colors. Anyway, so first I will tell you, okay, what's vector? So vector consists of two parts. So it has a long, it has a length and the direction. This is not the standard definition because in linear algebra, you may study it in the future, they have a kind of abstract one, but for us, just say, okay, if a quantity that has a length or direction, we call it a vector. Okay, means that the vectors, the means by the definition, we know vector has two sides, right? One is the length, where maybe Americans like to use the magnitude, right? And or magnitude, and the second one is the direction. So we have to try to, explain. So what's the direction? What's the length? So how do we compute the length? Is so this kind of question. So the first, so in the book I said, okay, when we are writing a vector, we have to use a bold. You don't have to when you're handwriting, where you can add the arrow. For example, we say, okay, alpha is a vector. So it's kind of notation. We say, okay, you say alpha is a vector, right? Sometimes say, okay, we write it in this form. Anyway, we can like this, where we say AB is a vector, like this. You write it in this form. We say A is a vector. Okay, it's better to write this. But if you use kind of the Roman letter, alpha, beta, gamma, it's clear. If you use the alpha, beta, no. The English letter, you have to, for example, use A is a vector, B is a vector, C is a vector, where you explain a vector A, vector B. If you can use this form, if you use the Roman, you don't have to write this. It's kind of the rule. Anyways, it's kind of the rule is you can use everything. If you use the English, describe it. Okay, you don't have to add the arrow. But anyway, I only add arrow in my high school. In college, I never add an arrow. But sometimes some school, some universities, some professors say, okay, you have to. I think it's their bias. Anyway, because in the textbook, never say that one. You don't have to write the bold one because that's the typing one. When you are writing, you don't have to add the bold like the A is so big. It wastes your life. Okay, this is kind of this one, and then let's come back to the geometry. How to understand the vector geometrically. So, for example, if we have point A, there is a large point B, and then we connect this. This is A, and if we only draw like this, draw it like this, it's just a segment, right? But if we add arrow, no, it's different. It has a length, right? And also it has a direction from A to B. The arrow means that from A to B. So, and for this case, we write the vector in this form. It's kind of the corresponding, it's called the displacement vector. Where the book says the corresponding displacement vector field of AB, A is called the initial point. Where you can say this is starting point, pretend you are here, you walk starting from A to B, and then this is the terminal point where you can say a terminal point or the stopping point. Some notation. Sometimes this is the point. I just write as PT's point. Anyway, that's fine. So this is geometrically, this is the vector, right? This is the vector. So maybe I just use the red one. Anyway, I'll try use less color because it's kind of confusing. Okay, and then let's record what we studied in your elementary school. Elementary school, we know how to add two vector together, right? A vector together. But how do we add a vector together for in three-dimensional space? Right. So first, so if we have a vector like so, it's kind of how do we do the addition, subtraction, multiplication like this? The problem is that okay, how do we do addition, subtraction, multiplication? It's basic for Mars. Oh no, for mathematics, we're just do operations, right? For everything we do the operations, how to add, how to minus, like that. For vector, how do we do it? So if we have a vector like this, okay. First, addition. Okay, so if there's a vector alpha, okay, we have another like this, beta. So first, say, okay, what's the alpha plus beta? By the rule, how do we understand it? Pretend that you are here, you're working from this place, we can write it A, this is B, this is C, or you can say this is A, B is C, you can say this is B, C is C, right? Beta is this, alpha is this, and then, so what's the addition? The rule is that pretend that you are starting from here, work along this segment, and continue from A, B to C, and then finally you got here. If finally we only look at the starting point and the terminal point. So this is a vector, right? And then we defined this as the sum of alpha and beta. Is it clear? Okay, this is called the triangular. No. And then you may say, okay, your picture is so special, right? So for example, we have like this is alpha. For example, this is beta. Now it's the picture is different, right? This is the end point. For the second one, the starting point at is the terminal point, right? How to add this? You cannot use a triangular rule. How? You first move this to this place. Okay, let me kind of like it's kind of you construct a parallelogram. Okay. This is beta. This is beta. Okay. If we move a vector parallelly, we think the vector are the same. I think you know this in Calc 1, right? Or in other Calc, or some of you may know this in your high school. And then this is also beta, if L. So alpha plus beta is kind of this. Okay. This is alpha plus beta. So I will try to change less color because otherwise I don't have enough time to finish what I want to talk. So this is about the addition. So, and then after talk about the addition, so let's talk about the multiplication. But here, when we have two numbers, you can multiply two numbers together. But for vectors, it's different. We have scalar numbers and we have vectors. First, let's talk about a number times a vector. It's called scalar multiplication. So if we have an alpha like this, if this is alpha, we can say this is A, this is B. It's the same. You can always do it in this way. And then we have a number, lambda is a number. This is a vector, alpha is a vector. Okay, we just make a rule. In the future, if I write the Roman number, it's always a vector because I will never use kind of, alpha beta standard number. Okay, this kind of, that's a rule, in mathematics department. Okay, and then the question is, okay, so what's alpha times or scalar multiplied by alpha? A long number or scalar or vector. So for example, I cannot just give you an example because if lambda is bad, I don't know. If alpha, for example, if lambda is 1, we have lambda alpha should be alpha, right? For example, if alpha is 2, how do we draw this? For example, if this alpha, okay, you just copy 1, you get C, you just move A, B to this place, get a B, C. Now it's kind of, you move A, B to B, move A to B, and then you get a B, C, right? The length is the same. This is 2 alpha, like 2 alpha. It's kind of, you put a 2 alpha together, you first work alpha, and then you continue work alpha. I think this is easier. And then lambda is 3. It's kind of, you work 3 alpha, right? So if lambda is 100, is 1 alpha means that you work 100 alpha. Okay. Anyway, you may say, okay, why don't you just give it an integer number? Because it's the other number. I don't know how to do it. That's the reason. For example, if lambda is 1.5, so means that you first, you have alpha. You just work another 0. Is 1 over alpha. It's kind of another half alpha. Like this, you get 1.5 alpha. So you might still ask me, why do you give pi alpha? How can I draw it? You just you can only think about it, right? Okay, for example, 1 is 1.6. Anyway, 1.6, 2, 3, 6, like that. You just do more, right? Okay. And now for the special case, okay, if lambda is -1, what will happen? So lambda alpha is negative alpha. So what does it mean by this? So it means that first you have alpha. This is alpha. Negative alpha, it means that you change the direction. This is the starting point. You just change the direction. This is negative alpha. After you know this, okay, you can compute for any negative number. For example, negative 2.5. So it's got you first kind of lambda alpha is negative 2.5 alpha. It's kind of like this because you already knew how to compute negative alpha, and then by the same rule for the real number, you know how to compute this. Okay, finally, we know how to compute this one, right? By geometrically. But finally, okay, you just understand this. But finally, we will never use this. Let's say geometrically know how to compute this. One thing you have to know, if lambda is positive, negative, for example, you have to change the direction like that. So this is called the scalar multiplication. Okay. You can say this is still a vector. Clear? Okay, and then let's go more. So it's kind of, you may say, okay, how do we understand this? So let's understand this. By the geometric definition, we know lambda alpha. Sorry. For lambda alpha, it has the following property. Has length, right? Say, no, alpha times alpha. This means that length of alpha vector. So maybe I forgot this. No, anyway, I just explain here. So this means the length. Sometimes I say, oh, the people use the double line, it's the same. Anyway, there's no rule, use a double or just one. Okay. And then we know if alpha is greater than 0, same direction as alpha. Lambda is less than 0, same. No, what I'm doing. No, I have to erase it because this information is very important. Opposite direction as alpha. Okay, I think that's fine. This is about the, the scalar multiplication. So you might say, why do you do this? You didn't tell me how to do the subtraction. So for the subtraction, so if we have alpha minus beta, how do we define it? We just alpha plus this. Because we know how to compute this. We know how to compute the addition, vector addition. So we know how to do the subtraction. That's about the basic operations. Is it clear? So for this part, so let's do a little bit of summary. So you have to know how to define the addition. Just know this. We will not test you, okay, draw a picture and explain. We will never do that part. But you have to know this. Scalar multiplication. You have to know this. Lambda alpha subtraction or differences. It's the same. Difference. Alpha minus beta is just this. 3 part. Okay, that's very important. Okay. So and then, so let's write a remark. So because I think I forgot to write it. So let's write a remark here where a formula is the same. If we have A is x1, y1, z1, B is x2, y2, z2. So the vector AB is x2 minus x1, y1, y2 minus y1. The third one is z2 minus z1. Okay. So for any 2 points, automatically we have the corresponding displacement vector. Okay, for display, how do we compute the displacement vector? You just use the terminal point subtracted by the first component, the initial point componently. Okay, every component you subtract them. Okay, that's fine. So we talk about the vectors. Okay, the geometrical picture, and then I teach you how to do the addition, scalar multiplication, and the subtraction or differences. Okay. So, and then let's look at some examples. So, I already forget the number. I will not use the number again. So the first example is about finding the vector represented by the direct line segment with, so it's kind of, we have A, B, this is 2, -3, 4, B is -2, 1, 1, and then find the, you can draw, first we have A, B, and then automatically we get a vector, right, from A to B. So the question is that, okay, you can imagine, okay, your segment where the vector should be some line, right? The line has a direction, right? Find it. The line direction, just the direction of the vector. Clear? So the problem is, okay, find the vector represented by the directed line segment with initial point A is 2. Okay, I already write this part. That's fine. So how do we find it? You just find A, B is -2, -2, 1, -3, 1, -4. So we got -4, 4, -3. So this is the direction of the vector, or the line of the direct, the vector of the line. Okay, there is the error. You can say AB is the vector AB. It's kind of useless. Okay, and also AB stands for the directed vector of this line. Is it clear? Hope so. Okay. So now we have a problem. So up to now, I didn't teach you how to compute the length of a vector, right? How do we calculate the length or max? Oh, because it's hard for me to spell this word of a vector. You may say, just draw a picture. No, like I said, that's unrealistic. So you have to, picture is telling some intuition, but it cannot tell me some precise information, right? So we know in 2D case, okay, let me change. In 2D case, if we have a vector, alpha is x, y, z, so the length, we'll write this form, is just x squared plus y squared. Okay, I think you know this one. And in 3 space, alpha in 3D, so this is x squared plus y squared plus z squared. Okay. Clear? So this is kind of formula. Alpha is x, y, z. The length of alpha is x squared plus y squared plus z squared. So important. Okay. And then how do we do the addition? How do we do the addition, subtraction? Or how do you calculate? Anyway, this is the formula. And then how do we do? It's kind of, I can say coordinately, not geometrically or algebraically. Okay. Wait. Algebraically. Or I don't like algebraically. How do we do the the addition? difference and scalar multiplication. Okay, let's look at it here. So if in 2 dimension, this is alpha x1, y1, beta is x2, y2, right? In 3 dimension, x1, y1, z1, beta is x2, y2, z2. So alpha plus beta, you just add the component correspondingly. Okay, alpha plus beta is x1 plus x2, y1 plus y2, z1 plus z2. Alpha minus beta is just x1 minus x2, y1 minus y2. Alpha minus beta is x1 minus x2, y1 minus y2. No, z1, z2. Okay, and now lambda alpha, this is lambda x1, lambda x2. Okay, lambda alpha is lambda x1, lambda x2. Oh, sorry. Lambda z1. It's quite simple, right? You may say, why not teach us this directly? Of course, you have to know some abstraction, some, know some intuition. Historically, the people has the intuition, and finally they have the attribute. Computation. Okay, it's not easy historically. It's very hard. Okay, let's continue. Okay, I think I have to go faster. Otherwise, I cannot do it. Okay, so let's go a little bit faster. Okay, because just some computation. Okay. Example. So first one is if alpha is 4, 0, 3, beta is -1, 4, 5, and alpha plus beta, you add them together. Okay, 2 minus this, 0 plus 1, 3 plus 5. This is 2, right? 1, 8. Alpha minus beta is this minus this. You get 6. I just do it directly. There is -1, -2. Alpha length is 4 squared plus 0 squared plus 3 squared is 25 squared is 5. Oh, one thing is about for our course, we can use the calculator, right? Anyway, if you say, oh, the computation is so hard, anyway, that's fine. 3 alpha, just use the calculator. Okay, and 12, 0, 9. Anyway, that's fine. You have to know this computation. Okay. Okay. So this is about the examples. And then, so let's make some rule because it's very important. How do you understand the 3-dimensional space? Or, okay, so let's go fast. Okay, in R3, so we know X, Y, Z is every coordinate, every point. We can write it in this form, X 0, 1, 0 plus Y 0, 1, 0 plus Z is 0, 0, 1, right? And we write I is this. Or some book, you can write in this form, or you can write it in this form. Anyway, that's not important. Okay, and J is 0, 1, 1. K is 0, 0, 1. You have to remember I, J, K, or I emphasize it, add an arrow. It's a vector. It has a name. It's called standard basis vector in R3. You may say why this is standard, because this is just X axis. This is Y axis. This is Z axis, like that. draw a picture. This is I, if this is X, Y, Z, this is J, this is K. Clear? I, J, K, this is called the standard basis. Okay. And also, let me say, I think you know this part. I just, in case you forget it, in R2, we have X, Y is X01 plus Y01. We have I 01, J is 01. It's called standard basis vector in R2. Anyway, you may just change a little bit. Okay. So this is about, you have to remember this standard basic vector because we will use it in the future. Anyway, to be honest, I will not use a lot, but sometimes, you know, for example, maybe other instructors like to use this format. In general, I will only use this one. They give a problem, I use this one to describe it. Anyway, you know, sometimes there are a lot of bias because if I like it, okay, this is, I say something important, but I will not do that one. Anyway, I'll try to tell you everything because you have to follow, you know, different people's, you know, files. Okay, so let's continue. We still have some time. So I will teach you, for example. So if we have alpha, this is I plus 2j minus 3k, beta is 4i plus 7k. You may say, what's this? What are you writing about? Yes, this is a lot of writing. This is just 1, 2, -3. What's this? This is 4, 0, 7. Clear? So you may say, why 7 is here? Because k is in the third position. You may say, well, there is no j because the j is 0. The coefficient is 0, right? That's why. Okay, if you look at what I wrote here, right? Okay, maybe I can write it here. Anyway. Oh, I cannot cancel it. Okay, let me write it here. Example. Alpha, beta. This is I plus 2j minus 3k. This is 4i plus 7k. Maybe first I tell you in general, this is xi plus yj plus zk. Why add? Because there are so many numbers. I just emphasize this is the basis, okay? And then you can say, okay, this is 1, 2, -3. This is 4, 0, 7. So how do you add it? Alpha plus beta. You may add them together. If you use this add, just 5i plus 2j minus, no, plus 4k, right? Or you just add this together. 1, 5, 2, 4. You can say they're the same, right? I mean, if you may say, I just like the coordinate expression. Anyway, that's fun, but you have to know this one in case other people like to use this. Okay, so just know this. This is very important. Just memorize it. Anyways, you don't have to memorize it. I think after you listen to me, what I say is quite easy. So, so this problem is done, and then, so let's talk about the vectors. Come back to vectors. Like I said, vectors has 2 sides, right? One is the magnitude. The second one is about the direction. Magnitude, what kind of magnitude is kind of the length, right? How do we compute it? Now we know how to compute it. This is alpha, This is x squared, y squared plus z squared. But sometimes the people doesn't care about the magnitude. We only know the direction. No, so there is a definition of it's called the unit vector. If we have a vector alpha in R3, like alpha is x, y, z, so the unit vector. So first, what's the unit vector? A vector with length 1. It means that the length is 1. Okay. If a vector, the length is 1, we call it a unit vector. But not every vector is a vector. No. Not every vector is a unit vector, right? So for any vector, how can we find a vector which has the same direction as this vector, but the unit is 1? So the method is like this. Just memorize. For any alpha, we can construct a vector u. This is alpha, and u multiplied by alpha. You can say, if I write in this form, alpha cannot be 0 vector, right? It cannot. Okay, you may say, you didn't tell me what's 0 vector. Just pretend you know. The 0 vector is if a vector, the length is 0. Okay, I can say, if length is 0, we call it a 0 vector. For example, for any non-zero vector, you can do this. So this is the should be a unit vector corresponding to alpha. What do you mean by that? So it means that we have alpha, it may not a unit vector. We can find a u, how? Just u multiply by its length. And then we can get a u. It has the same direction as alpha, but the length is 1. Clear? This is very important. It's kind of a formula. A lot of formula, now when I look at a formula, it's kind of the baby's milk in my home. We call it a formula, right? But it's in the math here. Okay. So I will not change the color because it's so slow. Okay. So let's look at the example. Unless I want to emphasize something. Okay. I use the color. In general, I use the black. Okay. So for example, now alpha is 1, 1, 1. So find the unit vector corresponding to alpha. So u should be alpha multiplied by alpha. So means that first you have to compute the length is 1 squared plus 1 squared plus 1 squared. You get 3, a square root of 3, and then we get this, and 1, 1, 1. We use the scalar multiplication in coordinate case. So we get 1 over square root of 3, 1 over square root of 3, 1 over square root of 3. Okay, this is the way to find the formula. I think in general, we will have a problem in the quiz to ask you how to compute the unit vector because it's very important, right? So like I said, in the test, in the class, if I write a formula, so means that kind of formula, it should be very important. If it's not important, I will just emphasize it. I will not emphasize it. Okay. It's weird. The room cannot recognize what I said. Emphasize. Emphasize. Anyway, that's fine. Okay, right. Nobody knows. So